Hello. Now we're going to have a look at an introduction to the idea of ratios. So ratios are just where we're comparing parts of groups together. And a related word is proportion, where we are comparing part of a group to the whole. And we're going to look at what that means in practice in a moment. So let's have a look at this example. The person next to you in class has 3 pencils for every pencil that you have. Let's write that as a ratio. So for every 1 pencil you have, they have 3 pencils. So that's the ratio. I have now written that in mathematical language. So I am comparing what you have to what they have. So we have 2 members of our group. We have you have 1 pencil, they have 3. That's the ratio, the relationship between the two. How could we describe that in terms of the whole? Well, if for every 1 pencil you have, they have 3, that means I must be dealing with groups of 4. If you think about the smallest number of pencils we could possibly be talking about, we'd be talking about 4 pencils, because you have 1 of them and they have 3 of them. So the total we must be working out of is at least 4. It could be bigger than that, but it's at least 4. So a quarter of the pencils would be yours, and 3/4 of the pencils would be theirs, the person next to you. So let's look at how this relationship can change, because it doesn't, if we're told that for every 1 pencil you have, they have 3, that doesn't mean you have 1 pencil. You could have lots of different numbers of pencils, but they have 3 times as many. That's what our ratio tells us. So if you have if you now have 2 pencils, how many would they have? Well, we know that the relationship is 1:3. So if you have twice as many pencils, you've now got twice as many pencils, it would make sense that they would have twice as many pencils as well. So if this is our relationship, if you have twice as many pencils, they should have twice as many pencils as well. So they should have 6 pencils. If they have 12 pencils, how many would you have? Well, we know the relationship is 1:3. If they have 12 pencils, what did we multiply by to get from 3 to 12? Well, we would have multiplied by 4. So they have 4 times as many pencils as we initially described. So that means that we would multiply our number of pencils, or your number of pencils, by 4 as well. So we would have 4:12. And in this way, we can figure out how many pencils we would have for different types of circumstances, because we know that for every 1 that you have, they have 3. Now, let's take this and look at another definition that can be important in these types of questions. So we want to write all of these ratios in what's called their simplest form. So simplest form just means that the ratio is written in terms of whole numbers, like 1 and 3 are whole numbers, 1/4 and 3/4 are not whole numbers, they're fractions or rational numbers. And we shouldn't have any common factors. So this would be the ratio in its simplest form. This would not be, because 2:6, 2 is a common factor of 2 and 6. So we'd want to divide that out to get back to our simplest form of our ratio, which would be 1:3. These are whole numbers that don't have any common factor. So let's put this into practice. What are we effectively looking for then? Well, if we have whole numbers, if we're given a ratio and we're asked to write it in its simplest form, if we're given whole numbers, then all we have to do is find the highest common factor and divide it out. If there is no highest common factor and we've already got whole numbers, we don't have anything to do. It's already in its simplest form. Well, what is the highest common factor of 10 and 15? It's going to be 5. So I know that I can double or multiply by 4 my ratios. I can also divide both sides. If we had 10 pencils is to 15 pencils, apologies. If we had 10 pencils is to 15 pencils in this example here, then what would be the simplest number of pencils we could be talking about is effectively what we're looking for our simplest form. So we divide both sides by 5, our highest common factor, and we end up with 2 is to 3. Now 2 and 3 don't have any common factors, so we can't simplify it any further, and they're whole numbers, so our job is done. We have written it in its simplest form. We can now see what the relationship is as simply as possible. Now, if we're given fractions to deal with, we need to get rid of them. And we know that we're allowed to multiply both sides of our ratio by the same thing, or divide both sides by the same thing. We've seen that that works. And we've effectively gotten a story here for why it works. So how am I going to get rid of this? Well, I want to know the smallest number I could multiply these two things by to get rid of the fractions. Now that's effectively going to be the lowest common multiple of the denominators. So just like when we would be looking for adding our fractions or subtracting them, we need to get the lowest common denominator. We need to get the lowest common denominator here. So what's the lowest common denominator of 2 and 3? That's just going to be 6. So we're going to multiply both sides by the lowest common denominator to get rid of our fractions. So 6 multiplied by half is 3, and 6 multiplied by 2/3 is going to be 4. So that is now 3 is to 4. This is our ratio, and it's in its simplest form because there's no common factor between them, and they are whole numbers. Now, if we're given units here, and the units are somewhat comparable, we're able to figure out how to write them in the same type of unit, then we should. So if they talk about days versus weeks or years versus months, then we should convert everything to being in weeks or convert everything to being in the same units, if that's possible. There are ways of doing these questions where you can't compare them. You might be talking about days is to euros, and we can't change them to be the same units. But where possible, we should change everything to be in the same units so we can understand the comparison we are making. So here I have 50 cent is to 1 euro. Now I definitely know how to write this in the same units. You could write them both in cent, or you could write them both in euro. I'm going to write them both in euro in this case. It would be perfectly fine if you wanted to write them in cent unless they told you specifically what to do. So I know that in 1 euro there is going to be 100 cent, and I've got 50 cent here. So if I know in 1 euro there's going to be 100 cent, then I want to know what is in 50 cent. That's my aim. So what did I do? I divided by 2. So I'm going to divide both sides of my ratio by 2. So half a euro is the same as 50 cent. So that's my first job. So I have half a euro is the same as, or is to 1 euro is the same as 50 cent is to 1 euro. So I've now converted to euro, and now I want to write this in its simplest form. Well, I don't want to have a fraction in my simplest form. So what's my lowest common denominator? Well, I know the secret denominator here is 1. My lowest common denominator is going to be 2. So I need to multiply both sides by my lowest common denominator in order to get rid of my fractions. So I have 1 euro is to 2 euro is going to be my ratio in its simplest form. And I have my units the same, and I have simplified to my simplest form. Now, if I'm asked for or if I'm working out a question and I get 4 millimeters is to 5 centimeters. This could be like the scaling on a map. If we've looked at maps of the school or something like that, we could have, or diagrams that we would look at for work in engineering, we could have 4 millimeters is to 5 centimeters. So we want to have everything in the same units, and then can we write it in its simplest form? So I'm going to convert everything in this case into millimeters. So I want to know what 5 centimeters is in millimeters. Well, I know my definitions for my lengths. So 1 centimeter is to 10 millimeters. Remember on your rulers that you would have with you in school, your centimeter marks, you might have your 30 centimeter marks on your school ruler. And in between each of those centimeter marks, there are 10 smaller marks. Those are the 10 millimeter marks. So that's an easy way that we can remember our centimeters is to millimeters, because we all carry around our rulers, so we're easily able to look at it and see the relationship between centimeters and millimeters. So if I know that 1 centimeter has 10 millimeters in it, I want to know what 5 centimeters would be. So I am going to multiply both sides by 5. And I have not left myself very much space there. My apologies. But I've multiplied both sides by 5. So 5 centimeters would be 50 millimeters. So I now know I'm dealing with 4 millimeters is to 50 millimeters. And now can I write this in its simplest form? Well, I can see I have a common factor of 2. So my highest common factor is 2. So I divide out my highest common factor. Should actually write that in. My highest common factor is going to be 2. And I end up with 2 millimeters is to 25 millimeters. And that's now in the same units, and it's in its simplest form. There's no common factor left. So that is what we need for our ratios, that we know our simplest form and that we're able to understand our story and translate it into our ratios.